welcome to the second Microsoft Certified Professional Community Meetup. Today, we're gonna see the basics of AI-900 exam for the Azure AI Fundamentals. Before we begin the presentation, I'm gonna say a little things about me. I'm a Microsoft MVP in AI, and I work as a web applications developer in ITT. I love blogging, and I'm most passionate about Azure and AI. So you can find my blog, where you can find articles about AI technologies and how-tos for Azure Cognitive Services, Azure Machine Learning, and for a lot of the things that we're going to talk about today. Otherwise, you can follow my blog or me in LinkedIn, GitHub, Twitter, etc. I would also encourage you to find the MCP group in LinkedIn for the Microsoft Certified Professionals in Greece, so that you can join and get more news on other events, other exams, and also get information about anything related to getting certified in any Microsoft technology. So today's agenda, it might seem a lot of information. It's not. I'm going to start with the absolute basics, so don't be afraid if you're just a beginner and you're not very familiar with all those technologies. And I'm seeing some questions in the chat. You can go ahead and type them in, and I'll try to answer as many questions as possible at the end of the presentation as well. So today we're going to do an exam overview. So what's included in the exam and what you have to know in order to pass. So that in large part is what is artificial intelligence. We're going to do an overview of machine learning as well, for those of you who don't know what machine learning and what it entails. We're going to see Azure Machine Learning tools and the portal. We're also going to see the Azure Cognitive Services Suite, which is the Azure AI. We're going to see how computer vision works, natural language processing. We're going to see bots, and then I'm going to tell you some resources regarding on how to study for the exam, how to get vouchers if you want to get started and want to save some money getting started. And there's going to be another meeting as well that's going to be a little bit more specific on what kind of questions usually fall in the exam and how to get ready to give. So make sure that you are you are in our I'm sorry, in our LinkedIn group, so you can get news about those sessions. What I'm trying to do today is I want you to leave this session and have a greater understanding of everything this exam entails, and you can even get in a conversation about artificial intelligence or Azure machine learning, and you can participate, and everything you hear you understand regarding the terminology. So this exam is about the basics. It has, I think, 5 modules. The first module you have to be familiar with to take the exam is artificial intelligence workloads and considerations. That takes about 15 to 20% of the exam questions. You need to know the fundamental principles of machine learning on Azure. You have to know features of computer vision on Azure. The basics of natural language processing workloads on Azure, and finally conversational AI workloads and anything else in Azure, which as most of other modules takes up 15 to 20% of the exam. Started. Artificial intelligence. What is artificial intelligence? Well, artificial intelligence is any kind of software that can imitate human capabilities. It can make decisions based on data and experience. It can recognize events. It can interpret visual or written input, and even spoken language, and it can respond, engage in dialogues and conversation, and help people complete tasks more efficiently and more quickly. So, in essence, artificial intelligence is any technique that enables computer to mimic human behavior. That entails machine learning, which is a subset of AI techniques which use statistical methods to enable machines to improve experiences, and deep learning, which uses multi-layer neural networks. The most common artificial intelligence workloads, well, areas of AI, let's say, that we're going to see today is machine learning. Machine learning help us create predictive models based on AI and statistics, on data and statistics. Anomaly detections are systems that usually detect unusual behavior or patterns. Computer vision are applications that can take visual input and analyze it in order to give us some results. Natural language processing enables applications to understand human language and respond likewise. And conversation AI is mostly what we refer to bots, like AI agents that we use to book an appointment and automate some procedures. As you can see, all of those workloads usually are combined and cannot be separated. So there could be an application that uses one or more than more than one of those techniques to accomplish a result. So in Microsoft Azure, Microsoft Azure is a cloud platform, and it has a suite for AI that takes care of your data storage, the compute, and gives you AI as a service. So the key Azure services that we'll explore is Azure Machine Learning, Cognitive Services, and the Azure Bot Service. But before we go and analyze all those tools and all those great APIs that allow us to make smart and human-like applications, we really have to see the challenges and risk with AI. Because, okay, it's easy to make an AI-enabled application. I will find an API, I'll create a model that helps me automate some things and learn. But while that's great in theory, there are a lot of challenges and risk associated with it. For example, bias can affect results. When you're training a model, it's very similar to, I don't know, training a dog or learning something as a person. What you do and how you train it will affect the results. For example, if I am training an application to identify party photos that are photos of, let's say, a party. So typically when we have photos at a parties, you might have food in the background, music, lights, drinks, maybe some of those, birthday hats, etc. But if you train using photos of only, let's say, Caucasian people and white people with dark hair, the application will learn that parties are gatherings of groups of white people with dark hair. So if you don't train your application to, let's say, recognize all types of people, all ethnicities, and all ages, it can affect the results. So you can get negative results. Of course, as it happens with every application, you might have errors. So errors can cause harm because, okay, if I create a face recognition machine that put hats on people like those one we have on Messenger, and the hat goes wrong or it's not implemented correctly, nothing happens. But if I'm implementing a robotic arm that will do a surgery, well, an error can be fatal for the person in the operating table. Of course, as with everything else in any application, data are very sensitive. All precautions should be made. The data are not exposed. Also, I know that AI currently is a trend. We all want to make AI applications, automation help us, but solutions may not work for everyone. So you have to be very careful which features you use so that the things you create are helpful and not just overly embellished with features that are not used or not necessary. And there's the most important thing when you're building an AI application. Users must trust a complex system, a system that will understand them, make decisions for them, and they have to trust that it's built that way to reflect a human judgment system. So that's very difficult to do. And the most important thing, which is also about trust, who's liable for AI-driven decisions? For example, if I'm creating an application with face recognition to prevent crime and someone gets arrested, that they are not responsible for the crime committed, who's liable? Is it the application developer? Is it the police for using the application? So all of these challenges must be analyzed and dealt with before you start building an application. For example, I think Microsoft does not allow its AI solutions to be used for police reasons in the US. I think you're going to see a warning if you go on the documentation. That is because there's an issue of liability on who is liable for those decisions. So it's very important to think about the ethical implications of creating AI applications. So this is what we call the principles of responsible AI. So in order to tackle these challenges and risk we talked about in the previous slide, we have to create a system that should firstly treat all people fairly. It's fair. Okay, so when you create a model of machine learning that rejects applications for, that's an actual example, HR application that screens people's resumes for job positions. It has to be fair. It has to be objective and not look at age or marital status or gender to make those decisions about who's best for that position. It also must be reliable and safety, because a lot of applications can be, let's say, applications just for fun. But for example, when we're thinking of automobiles and self-driving cars, reliability and safety is a big thing to have. Of course, there has to be privacy and security as in any other application. It should be inclusive and not exclude any groups, and it should make people feel engaged and benefit parts of society, not harm them. It should be transparent. Me as a user, I want to know what the application does, how it automates things, and how it helps me. And it should be accountable. Every AI application should have clear goals and clear liabilities to ensure that the solution meets the requested terms. It's useful, and if something goes wrong, there's someone responsible for it. You can find all those principles in the link below, microsoft.com AI, responsible AI, and read about them. So this is one part that you should be familiar with for the exam. So let's go and see cognitive services. Cognitive services is the Microsoft suite for AI. It's actually a set of ready-to-use APIs for every developer to use that do not require machine learning expertise. There are a lot of categories, a lot of APIs. You can see it in language, speech, machine learning, vision, search, and knowledge. We're going to see most of the services today. And in order to use them, you would have to have an Azure subscription. Okay. There are standalone resources for specific services. There's a general cognitive services resource for multiple services. I will explain what that is in 1 second as we go to the demo. In essence, it's an API. So you would need a REST endpoint to use it and one authentication key. So you built an application to read this REST endpoint by using the authentication key, and you are able to use pretty much all cognitive services. Maybe the calls are a little different or the models you use to call them, but in essence, cognitive services are pre-trained models that you have at your disposal, and you don't really need to have any expertise to use them. So I'm gonna go back and forth with this. I thought it would be better to cover each section along with its own demo. So let's go and see the cognitive services. Okay. For those of you who have never seen the Azure portal, this is the Azure portal. Here we have some services. This is the menu, which you get some, you can group your favorites. So if I wanted to see my, I don't know, SQL databases, I would go here. There's the home. You can build dashboards in the Azure portal. The Azure portal is the way to manage all your services or your cloud resources. Typically, what you have, let's go, okay, I'm gonna go here. Typically in Azure, what you have is a subscription. You can have multiple subscriptions. So for example, I have 2 here. Then you have resource groups. Resource groups are used to group resources together. So it's to make sense of your resources and to be able to find them. So today I've created our research group to group the things we're going to see today. And to create a resource, all you have to do is go to the Azure services. If you don't know what you're looking for, you can go ahead and click on the category. Otherwise, you can click on the Add Azure Resources and create a new resource. Here it's the marketplace. You can see all the categories, or you can go and search for it. So as I said in the slide, let's go back a little bit. All we need to consume cognitive services is a REST endpoint and an authentication key. So the first thing we need to do is, well, know which cognitive services we need, right? Okay, let's go Azure. Okay. As soon as you type and search for Azure Cognitive Services, you can go to Microsoft.com and find all the cognitive services. Here are the categories, and you can find the available services. So you have language understanding, Q&A maker, text analytics. Just as an example, let's say I want to create a text analytics. I want to detect language in a text. I would go find the product that interests me and create an Azure subscription. If you don't have an Azure subscription or you don't want to pay for it, you can create an Azure trial. It lasts for 1 month. It gives you about $200 for usage in that month. and you can test any services during that time. If you choose to, you can keep your subscription and convert it to a pay-as-you-go subscription, or at the end of the trial, if you don't want to proceed, you can just end the trial and don't pay anything else. The only thing you would need to create an Azure trial is a Microsoft account and a credit card. Don't worry, it's not going to charge you. It's just to verify the account. And it takes about 5 minutes. So you're ready to get started. So we have our Azure subscription. We logged into the portal. And now we're proceeding to create an application with text analytics product. So what you would do is you would search for text analytics. Okay, it has some suggestions here. I'm going to choose the text analytics. It gives you an overview of what this does, the plans of what this does, and you can go ahead and create it. When you create a new resource, it usually asks for some information. That depends on the resource you're creating. For example, here it's very simple. You need to add the subscription. You can add the resource group or create a new one if you don't have one. You can add the region. This is important because when you have services in different regions or regions that are far away from your location, it might incur charges in some services, not all services. So you must be familiar with the service you are using and whether the region is important for this service. You have to give it a name. You can do it anything else you want, and you give it a pricing tier. So everything at Azure has a pricing tier or a plan. You have to be familiar with the charges for that specific plan. Most cognitive services charge you for the call. So it's like 20,000 transactions per 30 days. It's the standard, and it has some pricing details. You can look for its service here. There's also Azure price calculator, where you can calculate the cost of usage for almost all Azure services. Okay, so this is how you create an Azure resource. So we can go ahead, push, and create. I'm going to create it. Okay. Let's go. While it's creating our analytics, I'm going to go here and see the resource I've already created before the presentation. Here it's an overview of the service you have created. In Azure, on the left, you have the properties of each service. It always has an overview, the activity log, the access control. You can limit access to each service. So if you're a big company and you have different teams, you can limit the usage, not the usage, the administration of those resources to specific people. These are for the resource management, so they could be different for other services, but every cognitive service has keys and endpoints. So these are the keys you use to use your resource. You would have to create an API call in code. You would use this endpoint and this key. The great thing about cognitive services is that they are a REST API. So it doesn't matter in which language. You can use Python, you can use C#, you can use Java, and any language to use them in your application. So it doesn't matter in what language the application is, you can use them just by using the API. Here you have information about the pricing tier, etc. So that's how easy it is to create a resource. And then if you have multiple resources, you don't even have to use a key for each one. You can create a cognitive resources key. And let me see if I have one here. Here, it's a cognitive key. This key can be used for all those services. So you don't have to create different resources for each one and different keys, which is the most important. So it's more difficult to manage. You can create one cognitive key to use with all your cognitive services. Let's see if I have some time, what time it is. Okay. So I'm going to show you real quick an example of a call. So this is actually the demo. If you don't know how to get started with the cognitive services, you can create the resource, go to text analytics, and get the samples. So if you download the quick start, this is what you'll get. You'll get ready API to try your service. So depending on which service it is, it has a different model that you use to query information, and cognitive resources gives you back the results. For example, this is a sentiment analysis example. So you would feed to it phrases, and the response would be if they're positive or negative. Okay, so that's a very, very quick demo of how Azure Cognitive Services work. It's very similar in principle. All you have to do is find your key, which has this this kind of format, and use your REST endpoint to make a REST call. Okay. So let's head on to machine learning. Machine learning. We've been hearing a lot of machine learning. It's the basis of a lot of things, not only just robots and these kinds of things. Machine learning is the process of programming the unprogrammable. Well, that means that I'm trying to teach a machine that when I have those 4 pictures, the first 2 are pictures of a face, and the other 2 are pictures of not a face. Well, that's the first step. Then you can teach it that the left one are fish in the sea, and the right one is a monument. So what machine learning does is that exactly, creating a model using digital data, images, language, text, anything you can think of, that's in bits and bytes, to create a model for the purpose. The purpose can be recognition, analysis, or anything else. So the best example of pre-built machine learning models, as we said, are the Azure Cognitive Services. We have so many categories, we can just ask how. It's because someone sat down with a lot of process and built those machine learning models for us to use. So this is actually the sentiment analysis. So when you go and type in, this is a great vacuum cleaner. I don't know who would say that, but anyway, the response would be that it's 96% positive. And this is how simple it is to get an answer from the Azure Cognitive Services. You just have the client, you declare the subscription keys and the region, as we said a few minutes ago, and you'd give it the input, and this would be the output that we'd get from the machine. This is mostly how all of the services work.
Can we make questions? Can we ask questions?
Yes, you can, but I would prefer if you type the questions in the chat so you wouldn't forget them, and maybe save them for the end of the presentation. I'll try to answer as many as I can.
Apologies, thank you.
Thank you. So there are 3 machine learning types. The first is supervised learning. Supervised learning is when I have a data set, have a lot of data. And what you usually would do is, I know the result I want. So we're going to see it in depth in the next slide. I'm going to separate those data in 2 categories, the training data and the testing data. And I will take this training data and create a model to, let's say, predict the value that I want. And then I would use the testing data to see if the model I created is correct. So this is called supervised learning, where I have a large data set with data that I already know the answer to, and I use them to create a model for future reference, let's say. The second type is the unsupervised learning, where I have a lot of data, but I don't know what I can do with them. So what I do, I'm searching for patterns and how I can create that model. Though this type of machine learning algorithm is called unsupervised learning. And the third is reinforcement learning. Reinforcement learning where it's not about the data or how I can create a model for the data I have. It's about how I can use the data I have to make the best decision possible. So for example, Google Maps or any map system does this. So I want to get from point A to point B the fastest, or the shortest route, or any other parameter. So it makes decisions based on the parameters I give the system. So machine learning algorithms, the most known are classification, regression, and clustering. And I would like to see them in depth on how these are used. So let's go ahead and see regression. Regression is one of the most common machine learning techniques, actually. You use regression when you want to predict a numeric value. So as you can see in this slide, how much, how many. I want to predict a number. So let's look at this example. In this example, we'll imagine we have a bicycle rental company, and I want to predict how many bicycle rentals I am going to have based on the day's temperature and weather conditions. Here we choose temperature for convenience. So I have some historical data because I know how many sales I make each given day of the year. Well, this is an example. Of course, there are many factors to consider in such a case, but let's just keep it simple. So the number of rentals, which is this column, the second column, is the number I want to predict, and the number on the left is the daily temperature. These are the features. I'm gonna call them X and Y. So what we're gonna do, what any machine learning algorithm tries to do, is find a function to predict this based on this. It sounds a lot like math, I know, and it actually is. It's really simple, so if you don't want to, you don't have to be caught up in the logistics of how the functions and the calculations are done. But I want you to focus more on the way and how we would calculate it in a perfect world where this was the only parameter we had. So let's put them into a diagram. So on the left, I have the cycle rentals, and on the bottom, I have the temperature. And I'm putting this as dots for each of those values. So around 56.
See the slides again. Sorry for the interruption. Cannot see the slides.
You cannot see the slides. Does anybody else have the problem?
No, we see them all right. See them just fine.
Yeah.
Okay. Can you how many people do not see the slides? Just one. If it's just one, try joining in again. Okay. Yep. The latency. I'm sorry. I can't do anything about it. I'll try to speak slower and make the transitions a little bit slower. But other than that, if you have a problem, let me know. And if it's just one or two people, try joining out and in again. Thank you. So where were we? So, oh yeah, we have the plot. So we are trying to see how many cycle rentals we have based on the temperature. So we took those data and put them in a diagram. So around 56 degrees, that's not Celsius, don't worry, it's Fahrenheit. we have around 115 rentals, and these are the actual numbers. So the daily temperature is the feature we want to use to make that prediction, okay? So what we'll do, we'll try to find a function. These are mostly on the same line. So what would I do is try and see on the dotted line how far along we are. And I see that for any given temperature, the minimum value is 35, okay? And this increases as I go. So I will find the space that for 1 unit of temperature, there's 1.5 unit of cycle rentals. I'm not going to bore you with a lot of math. So this is an approximation of the function that I would create to make that prediction. Okay. So looking at this trend, we have found our function. So I have this data. I want to use this this is the training set and this is the test set. I want to use this set to validate that the function I have found is correct. So these are the results of the function. As you can see, we are a little close. For example, my function predicted 116 sales and I had 114. Here it predicted 128 and I had 129. So as soon as I have this, I have the prediction. As soon as I have validated that this function is, well, close to the reality, I can use it to create my model. So it's simple as that. And that's actually called linear regression because it's based on a linear function. And then what I would do is try to improve this function to get this line as close to the reality as possible. This is where more and more data come from, because when it comes to predicting algorithms, there are a lot of factors that can make that prediction. For example, before the pandemic, we had a lot of bicycle sales, but they were mostly steady, more sales in the summer or more sales during, I don't know, competitions or whatever. But now it was a huge wave of bicycle rentals, of people buying bicycles because they didn't have other means of exercise or moving around during the pandemic. So my prediction algorithm wouldn't factor it. So as with any machine learning model, you constantly have to improve and constantly have to go back to training so the system can learn from itself. So that's how regression works. The second most common algorithm is classification. So one thing I forgot to mention here is that regression is a form of supervised learning because I have a training and a test set data set. Classification is, oh, sorry. And as with any other machine learning algorithm, we start with data. So here I have data. On the left, there are measurements from patients, from medical probabilities. So this could be the result of a blood test or weight or height, etc. And this is the probability of a patient having diabetes or not. When we have those type of yes-no situations, we usually assign them values 0 and 1. 0 is the not having diabetes, 1 is the yes having diabetes. So we have a lot of measurements and we have the results. We can proceed and separate the data set as well to training and validation as we did with regression. Okay, now we have to take those values and apply them in a different way, because here we don't have a linear function. We have measurements, and then we have the probability of a person being diabetic or not. So we're gonna put them in a plot like this. So these values are done based on the maximum. So you can see that's increasing on the values. And then what we do is split those results in half. I'm creating a line where I say that the results that are below 50% are measurements that belong to people that don't have diabetes. And any measurements above 50% are measurements that belong to people with diabetes. Okay, this is a threshold value. The threshold value is something that we decide on based on the data we have and the nature of the problem we're trying to solve. Okay, so in this case, it was decided that patients with the values below 50% would be people nearing zero. Okay, so as soon as we created that plot and we have the threshold value and we have the values, we're trying to create a function like previously that fits the data we have. As we can see, it's not a linear function, okay? If you want to know, this is a logistic function actually. And it represents the probability of people with measurements being diabetic or not. So as soon as I have determined this function, I will create my model. So the probability of people being diabetic using those measurements is 0.2. It's this dot here. And the probability of not being in this measurement, it's the exact opposite, because these both values should equal 100%. Okay, so the first result seems that is 0. And then we compare it to the validation data and we see that it's correct. We do this for every line and see the second is correct. The third is correct. It isn't. We have a wrong prediction because it predicted that the person might be diabetic where it isn't. And the person won't be, but it is diabetic. So then I would take this little table and make a matrix, the probability matrix. Sorry, I moved a little fast. So these we have the predicted values and this is the actual values. So I have one result that the predicted was 1 and it's actually 1. One result that the predicted was 1 and the actual is 0. That's a false positive. That's what we call a false positive. And the other case. So it's not diabetic, but the actual was 1. So it's a false positive. And it was predicted that the person wasn't diabetic, and he or she is. So that's called a probability matrix. If we have a lot of data, it transforms like this. And the more correct values we have creating this matrix, the more precise our results and our models are. And that's how classification works. We're trying to classify whether a set of values exist in a group or not. Okay. This creates a table that's called precision and recall, and we're gonna see it in custom vision in a few minutes. Okay, and the third one is clustering. I'm going to go ahead with clustering and our demo. And then if you want, we can take a little break. How does that sound? Okay. You can write to me again once that time comes. So clustering, as with all the other algorithms, we start with data. Regression and classification are okay. So bear with me for, I think, 10 minutes, and then we'll go into a break. So regression and classification are both forms of supervised learning. This is a form of unsupervised learning. This is clustering. So we have some observations of flowers. Clustering can be very vague in the data we can put to it. So let's say here we have a table with flowers. Here's the height of the flower and the petals of the flower, okay? And someone has assigned me to create categories for it, okay? So the features we have are not numeric values, but more quality values, if you know the difference. So what we do in clustering, we think of those values as coordinates. So starting from left to right, I'm trying to categorize the flowers. So I have this flower, it's 1, so I go 1, and 3 petals, 1, 2, 3, so it goes here. This is two boxes, let's say high, 2 centimeters high, and it has 3 petals. So it's still 1, 2, 3, but now it's 2 boxes to the right. I do this with all the flowers. So now I have coordinates of all those data. Okay. Then I have to decide how many groups I want this to become. Because here it's a little bit obvious that this needs some trial and error sometimes. But let's say I wanted to group those flowers in 3 groups based on the data I have. So what I do is create 3 points. Those points are called K points, K as in kappa. Okay. And you simply assign those points at random in this coordinate system I've created so elegantly. Okay. So we're using 3 points for 3 groups of flowers. Okay. Each of those points, I want it to be the center of those groups or clusters, as we call them. Okay. So what I do is create 3 random points, and then I assign to these random points the flower that's closest to them. So it could look like this. So this is the center, and from the center, this is the first closest flower and the second, or this and this. As soon as I have made an initial grouping, then I proceed to move these points to the closer to the average of all the flowers in their group, not all together. So what would happen is this would go to the center. Okay, this procedure has to happen like a lot of times because, as I said, it starts randomly. Okay, and then slowly I will determine the best clusters for the groups. So what I could see visually, but I couldn't programmatically, is that these are the best groupings for those flowers. That's how clustering works. And I don't need to have training and validation data because these values do not have prediction or something like that. This clustering technique I've shown you is the k-means clustering, and you'll see it a lot on machine learning. So as I said, we have machine learning. We have supervised learning, which we saw 2 algorithms, classification and regression. And we have unsupervised learning, which has clustering and other algorithms. The one we didn't see is reinforcement learning. These algorithms are a little more complex, and they're used to make real-time decisions, robot navigation, learning tasks, new skills, and this kind of, they have this kind of applications. Okay, we can speak forever about machine learning and machine learning algorithms. So what I want you to take from this is the most important thing in machine learning is preparing your data. Data is everything. Data is the reason your model succeeds or fails, while your predictions are correct or wrong. So you have to be very, very aware of having a good training and testing data sets. The second thing is you build and train your model. You create the function and you start testing it and seeing the results, and then you run it, you get the results. If you're happy with the results, well, that's great. If you're not, you go back to the start, you prepare your data again. Maybe you did some mistake, maybe there were outliers you didn't think. Outliers are data, for example, that's how anomaly detection works. You have a lot of data that have similar behavior, and then you have some points that go away from the graph you have just created. Those are called outliers, and in many algorithms we ignore them because we consider them exceptions, so the exceptions cannot define the rule. You have to go back to your data, build and train them, run your models again, and that's a forever ongoing process. Okay, I'm going to show you a little bit of the Azure Machine Learning portal. The Azure Machine Learning is actually a cloud-based environment you can use to train, deploy, automate, manage, and track your models. It has everything in it, from data, compute, workflows. You can create workflows, you can have version of your workflows, you can register your models, you have metrics, you can deploy your models and use them from one portal. It works as all Azure ML workspaces. You have your workspace where you have your data, your compute, which are usually virtual machines or containers if you're using some kind of Docker or Kubernetes service. You have application insights for metrics. You have a storage account for your data. This workspace belongs in your resource group within your subscription within Microsoft Azure. And this is actually up to here how I showed you previously all of Azure works. There's also a great feature called automated ML. So we have a lot of algorithms that already know how they work, what they do, and what kind of data sets they apply to. Each algorithm has a specific data set it responds better to. So we have the automated ML, where you just give your data and let Azure Machine Learning find the correct algorithm to use to get the results or the predictions you want. All you have to do is give the data, give some optimization metrics and constraints. You can build a model for years, but I'm probably guessing you don't have years. So you can say, train my model for a day or for 2 days. And depending on how you train your model, you usually get better results. And it goes to an automated machine learning machine that gives you your machine learning model. There's also the Azure Machine Learning Designer. It's a visual tool for creating workflows. So you can, on the left, you can see the workflow. You have a training pipeline where you create this model and train it using data, changing those algorithms, trying new ones. Then you can create what we call an inference pipeline that predicts label from new data. And then if you're happy with the inference, you can always go back to training, or you can deploy this pipeline as a service for your applications to use. So training, building, and running, essentially, as I said before. The great thing is about Azure Machine Learning is that it keeps versions of every one of those things. So you can always go back, change, and go forward. This is an actual example. You have a diabetes dataset. There are some things you can do with your dataset, like normalize data, I don't know, remove empty values. Data are not always perfect for you to use. is what we said previously. You split the data into a training and a scoring model. You choose your algorithm and you evaluate your model. That's how Azure Machine Learning Designer works. So you can do everything we just said without using tools or code. You can do it using a visual tool. The tools you have to use beside Azure Machine Learning Studio is the Azure Machine Learning SDK, the CLI extension. This is kind of a command line to control all your Azure resources, and it's not specific to machine learning. You can do it for all Azure resources, and you can always use Visual Studio Code. So let's go get a quick overview of the Azure Machine Learning portal. And then we're gonna go on a 5 minutes or 10-minute break. So let's see. This is the Microsoft Azure Learning Portal. I have already created a workspace. This is a whole workspace that you create, okay? It has two pricing tiers. One is the basic, and the other is the extended, but the extended is the more interesting one. The extended has the designer and the automated ML. Here, you can see all your assets. You can find data sets. If you're a beginner, you can create a data set, or there are open data sets here you can find, for example, sample for diabetes, US consumer prices. So you don't have to find external data sets to experiment with. You can use the ones already provided by Azure. Leave, yes. Experiments are the well, let's say experiments is what we call the, well, experiments, I can't find another word for it, that you do by using a data set. So let's open an experiment. An experiment contains running status of your model, how to create it, the designer, etc., and some charts or anything else. Pipelines are the versions I said. Everything runs as a pipeline. So you see, I even have the individual runs of my model, so I can always go back to it. This is for a movie recommendation service, for example. Here you can have your models, you can package them, you can use them. Let's take a look at the designer. Let's open the movie recommender. So here is a movie recommendation service. You get IMDb movie titles and pair them with their ratings and use this algorithm to predict the rating of a movie you want to see based on other similar movie ratings. That's what this does. Really, really quick. You can have Python scripts in here. These are all the modules you can use to create those, to create this model via the designer if you want to. Statistical functions, etc. And this is the automated ML, which in concept is you create a new run, you give it the data set. I don't remember which data set. I think I usually use the weather set. You give it the data set, the algorithm, what you want it to do. Okay, this is not going to run because I haven't configured some compute and virtual machines on the background. But it's like a wizard. You create a data set, you configure the run, and you get the results. Okay. And these are the results from previous run. This is weather data I found on GitHub. So it created a lot of models based on what it thought an algorithm was useful. And then you go through all those algorithms and see which one is the best or actually got the results you wanted. I used this to predict weather by using weather dataset from GitHub. You can find a lot of, if you don't like the existing, data sets that are in Azure. You can find them a lot on GitHub, and well, you can write open source data sets. You can find anything from Twitter data sets, airports, flights, anything you can possibly think of. And here you can manage the compute, like the virtual machines that run your models, the data stores. These are databases that can be anything from files to SQL. And notebooks. These are Azure notebooks that you can use for documentation. Let's open one. So this is a how to use Azure ML. And let's see. Let's find this. Let's see. So this is a table of contents, introduction, and environments. So you can have a lot of notebooks here for Python, for samples. You can even run these samples within the notebook. The reason I'm showing you this is that some of the Learn courses in Microsoft Learn use notebooks to guide you through the exercises when preparing for your exam. So it's good if you're familiarize yourself with Azure notebooks. Okay. So this is it for a brief overview of the Microsoft Azure machine learning. I know it's a lot of information so far, but I think that was the hardest part of our presentation so far. The rest of the services are easier to use, don't have a lot of terminology, so I think you'll find them a little more light. That's why I left them for the end of the presentation. So let's go for a 5-minute break. Is that okay? And let's get back to see the rest of the services. We're going to start with computer vision next, so I'm going to leave this here.
Οπότε να πάμε να βάλουμε καφέ.
Λοιπόν, hello, are we back? Is everything here? Everybody back? Did you get your coffee and everything? I hope.
Yep.
Okay. During the mini break, I tried to answer, well, I think all of your questions from the start of the presentation. So if you asked a question, please refer to the chat for an answer. If you have more, we'll discuss it at the end of the presentation. If you have the time. Okay. So I will be moving on with computer vision. What is computer vision? Okay. Okay. So computers don't really read images or see images. They get anything that digital data from cameras, videos, images, photographs, etc. So the way they see those digital images is actually well, bits and bytes. Each image is an array of numeric values that indicates the color intensity of each pixels. And when we're talking about colorful images, you get 3 values for the color that synthesize each pixel. That's well, as simple as I can explain it. So that's how computers understand and see images. So what we do when we're using images, we're training the computer to interpret those changes in color, intensity that make up an image. Okay. There are a lot of applications of computer vision. The first is image classification. So an image classification model uses the pixel features we talked about to predict a class label for the image. For example, this is a picture of a taxi or a picture of a bus or any type of vehicle or building. That's what classification does. It classifies the content of the image and gives it, let's say, label. Okay. There's object detection. Object detection models are trained to classify specific things within the image, but they don't give, okay, they give exact coordinates, let's say as a rectangle. Okay, so you can identify a bus, a car, a cyclist, and generally whatever you have created your model to identify. Okay, so what the answer we're trying to give when we're talking about user detection is what objects are in this image and where are they. Semantic segmentation is, well, an advanced object detection where you have pixel perfect representation of the object in the image. So you no longer have a set of coordinates that show that there's a bus, well, around that part of the image, but you also recognize the picture. These are used to create those kind of, let's say, overlay masks for those objects. And we've seen it a lot of those kinds of overlays. For example, in maps, you have different colors and overlays over specific countries. So you can't mark a country with a rectangle, right? You have to have the exact coordinates for each pixel in the image map. By using those techniques, you can build and create image analysis. There's something wrong with the PowerPoint. It's behind my bar. So by using image analysis, what you do is create labels. So this is an image of a person with a dog on the street. I know you can't read it, but that's what it says. And then we go ahead and go in face detection and recognition when we recognize where the face in an image is, and we can recognize to whom that face belongs to. And there's optical character recognition where we recognize letters and texts in images. either printed or handwritten. So the computer vision service is used to create an image analysis. And this is part of the cognitive services. It uses pre-trained computer vision models. So by giving it an image, you get some information, for example, a caption, which is, let's say, a label for the image. So if you gave it that image on the right, you would get the caption, a group of people walking on a sidewalk. It gives you tags of specific things it identified within the image. It gives you a rating, whether the content of this image is adult or not. And it can help you identify over 10,000 predefined classes, which means objects. You can get the image description and tag generation. You can detect where the faces are and analysis, and the cognitive services image recognition automatically recognizes famous people. So if you're famous, your person is, it can probably show your name on the picture. It helps a lot with content moderation. Content moderation is a cognitive service that helps you identify adult content and inappropriate content in images in images and video. And text, which is very helpful because, for example, you can have an application that moderates comments on a school, I don't know, blog or etc. You don't want it to have like mature content on it or anything offensive to certain people or things. So content moderation is very helpful. And you can also detect text and optical character recognition, either handwritten or digital. So when you're training models and the computer vision service is not enough, cognitive services, and there was a question on it, if they can be expanded. Well, there are certain services that, just as the computer vision, that goes with the custom vision service. So the custom vision service allow you to create your own model to do image classification and object detection. And we're going to see it in a demo in the next few minutes. Of course, you can analyze faces with the face service. It does facial analysis, age analysis, and emotions. So it gives you a rating from 0 to 1 probability of the emotion detected in the face. It also contains facial recognition. It can match similar faces, and it can verify identity. So, for example, if you train the service with specific faces, it can then identify the people in those faces. As I said, the computer vision service also contains the optical character recognition, either printed or handwritten. There are options for quick text extraction from images. You can make an asynchronous analysis of scanned documents, and even recognizes if you have, you have a digitizer and you write handwritten notes directly to the computer. You can also fit that information and get your text in, well, if it's legible, of course, to an extent, from the computer vision service. This is one of the newest services. Well, newest, it was last year, but it's from the newest additions to the computer vision. It's the form recognizer. The form recognizer extracts information from scanned forms or in images or PDF format. But that's not the innovation of the service. The innovation is that it gets information from image in key value pairs. So when you have, for example, receipts or I don't know, medical documents in paper, and you have to scan them that have a specific format, it can digitize and extract all the information for them, either in key value pairs. So let's say, for example, you have a form that says name, surname, etc. It will get this value and say the name and the recognized value. Or in tables. So if you have receipts and go one apple with 90 cents, 160, it will recognize this pattern as a table and still read those information. So the purpose is to, if you want to digitize information from records or old paper, it's a really helpful service to use, and you can train it with your own data to recognize your own specific receipts or anything else. So it's not just extracting text, but actually categorizing it and recognizing where it should go of those fields, which is very helpful if you're building an API for an ERP and you want to input those information and make them digital. So let's go see how the custom vision service was. The computer vision service pretty much works as with any cognitive service. You feed the service an image, and what it does is give you information on it. And you can actually, I'm gonna make a little pause here and show you that you can try most of the cognitive services online. So let's say, for example, I am interested in, let's say, using the computer vision service. So let's go to vision, computer vision. Most of those services have a demo on the page. So if let's say, okay, let's upload an image, analyze image, and I'm going to browse. I'm going to use this. This is the test for the computer vision. So it's uploaded. I didn't find any objects, but it says the name is clothing, close to 100%. It's a shoe. It's, well, 100%. Footwear, it gives you some tags and the probability that those tags are correct. So it gives you this information. There's a description. So the caption could be a pair of shoes with an 80% confidence probability, and some information about the image format, if it's black and white, if it contains adult content, and every score the service gives you is accompanied by a probability score. We saw the probability scores previously in the slide of when we're talking about Azure machine learning. I don't know if you remember this. I'm going to go back the slides again. So you see, we're predicting values from 0 to 1, and our algorithm gives us a probability score of the function it created. This is the same probability score the cognitive services give you regarding anything that they have found. Okay. So if you want to play around with the services without creating an account, most of them do have a little demo in their page. So this is actually a call to the REST API for computer vision. This is the results you're going to get in JSON format. Okay, but this is a service you can extend and create a custom vision project. This is created in its own portal, customvision.ai. All you need to create a new project is the name, the description. Important to remember that all the cognitive services are Azure services, so the billing is always done in the Azure portal. So to use them, you have to have a key and an endpoint. So here I see the service to create a new project sees the keys I have available in my subscription, asks me what kind of project types I want to create. And for this example, which actually you can find on my blog on how to create it, you give it a name, a description, its classification. I think it's multi-class, single tag per image, and the domains is, let's say, a category it exists. Okay, the compact domains regard the model that it's going to create it. If you chose a compact, the model you create can be extracted and it can be used for, let's say, mobile use. It can even be extracted. I don't remember the exact format, but it can be used by other services as well. For example, machine learning framework or completely different services than Azure or anything else. So you can create a model and download it from this portal. So this is the branch project. It's already created. What I have done is I have downloaded a lot of images from Google. And why isn't it opening? Okay. And what I did is get shoes from two brands, Adidas and Nike. This is not a sponsored project. I must say that nobody paid me to. There's a random brands. So what I did is I uploaded 2 sets of images and I created a tag on it. So it's an Adidas shoe or a Nike shoe. Okay. And I can create more images. I can filter the images and see what I have uploaded. So once you upload the image and give it a tag, which is, well, a fairly simple procedure, you go ahead and train your model. I think I've already trained it once. And actually, the Custom Vision AI portal keeps track of your iterations, how many times you train it or what changes you make. So you can have different versions of your model creation. So the steps are, you find the images, you create a model by categorizing, classifying these images to be of one brand or another brand. The portal is fairly simple. You add the images from here, has a browse. Here's my folder. Once you add a new image, let's see, you can create the tag here, even if it doesn't exist. It uploads them to the portal and gives you a summary. I'm going to do that now. If you upload too many images, you can even find the untagged images, so you can tag them. You train your model and then you can test it. You can test it by browsing local files or entering an image URL. No, I don't have a URL. I have a local file. So let's browse my local files and go to my desktop. Where is it? Oh, it's not here. Oh, here it is. I have a Nike shoe. It analyzes the image and it predicts the probability that it's 99.4 Nike Adidas. Here I can have as many tags as I want. Here to quick test it, I can have multiple iterations. So in the first iterations, I could have only those 2 tags. In next iterations, I can put different brands of shoes. And as soon as I have this trained, I can use it as an API. I can publish. This can be published to create predictions. Oh, here are the data I've already tried with the results. Here I can see the performance. So that's a fairly simple test, the brand test, because they have very distinctive shoe logos. So that's the precision and recall. Remember the metrics we saw in the machine learning previously. I'm going to show it again in case you don't remember. I left. So this is the predicted outcome and the actual. This is the way these are measured, and you can see like precision is the number, how likely it is to be right, how likely it is, what is the likelihood your model will be right, and what your model does actually. So you can use these performance metrics to see and update your model. And here we have the probability threshold. Remember the going back to the PowerPoint again. This threshold here we talked about that it can be to 50% or it can be higher and lower depending on the circumstance. You can actually change it from here. So if you are familiar with machine learning concepts, you can use the portals provided by Microsoft and all the cognitive services to create solution and interpret those results. Because as I said, cognitive services in essence are pre-trained machine learning models. Okay. So the basis doesn't change. If you know the concepts of machine learning, you can navigate all those services and incorporate them to your solution. And as soon as you're done, you can publish your model to be accessible by an API, and you can export it. But as I said before, only iterations trained using a compact domain can be exported. It's a little detail that, well, you don't need to know it, but it's good if you do before you start your project. So that's how custom vision works. And let's go ahead and see a little more services. The last thing, well, the next to last thing we're going to see today is the natural language processing. Natural language processing is the process of building applications that can understand natural language. What it is, it's text analysis and entity recognition. It's sentiment analysis, understanding whether what I'm doing is positive or negative. Speech recognition and synthesis to be able to recognize speech and create it. Translation, either real-time or text translation. And semantic language modeling to be able to understand the structure of a language. What's a verb? What's an object? What's an article? Let's say. So in essence, that is those are the tasks natural language processing has. In Azure, that be accomplished with the following cognitive services. Text analytics, which contains language detection, key phrase extraction, entity detection, sentiment analysis. Speech, which is text to speech or speech to text, and translation. Text translation and custom language modeling, which is the demo we're going to see today. The language understanding. You can build your own model by using the provided portal to create your own language model without requiring programming expertise or machine learning expertise. So text analytics. I had a wonderful vacation in France. What do you think? What can I say about this phrase? Well, it's English. Text analytics can detect language. The sentiment returns 88% positive, and it found the key phrase is wonderful vacation. This is what text analytics do. You would send this phrase to the API, and this will be the response you will get. This is an example of a text analytics service. Speech recognition and synthesis. That's simple to understand, I think. You can use speech to text to transcribe speech to text. Teams is already doing this for us right now because when it does a recording, it transcribes the speech to text. So it's available either the recording as is or just the text that I'm speaking right now. And the reverse, text to speech. So you can have text and the speech voices can generate audible speech. Now that I said that Teams already have speech to text, if you see most Azure Cognitive Services are already incorporated in a lot of Office 365 products, and a lot of Microsoft products already offer the APIs, the models, and everything you can use to make your AI-enabled apps in their own products. For example, you have dictation in Word and Outlook, or you can read your email out loud. It's fun if you think about it, that so many services, AI services, are already incorporated to products we use every day. Translation, well, you can translate text or translate voice in real time. And language understanding, which is the most interesting service, one of the most interesting services for me. I really like this service because you can use language understanding for building bots. So what language understanding does is enables you to train a language model that can interpret language, natural language commands, let's say, how we talk to our virtual assistants. Behind it, it's a natural language model that understands our commands and makes our intents happen. So if I say to my virtual assistant, switch the light on, this is a phrase, or as we say in language understanding service or LUIS, utterance. This is a phrase. So the user said, the light is an entity. Entities are important when it depends on the context. If we're talking about smart homes, light is a device. If we're talking about a booking system, cities are an entity. Or if you're going about flights, airports are an entity. Those are entities. The intent is what this phrase is intended to do. So switching the light on is intended to switch a light on. So that's how we train a language understanding model to understand this phrase. So let's go see an overview of the portal really fast. Let's go back here. So this is the Language Understanding Intelligence Service, or LUIS, LUIS.ai. You can use LUIS AI portal to create conversational apps. This uses machine learning to train and build your model. You can create a new app from here. All you would need is, as I said, for all cognitive services, and I'll keep saying it, all you need is cognitive services key and an endpoint to use the service. So you use the portal to build your model and Azure to use it as a REST API. I have a travel agent example here. There are a lot of examples if you search for LUIS examples, because you can create apps, can be exported as JSON. So you can find already made examples on the internet if you want to experiment. Let's see the travel agent applications I have. This is an application that has 4 intents: to book a flight, to order an espresso drink, or to order food, or to get a forecast. There's no limits to how many things your application can do, but it's best to create intents that have meaning for your application. So for a travel agency, the espresso drink, those 3 intents are useless. All they would care about is how to book a flight. So the first thing you do is create an intent. What do I want my application to do? I want my application to recognize when a user wants to book a flight. Let's go see the example. This is the intent, as I said. So how many ways do you have to say to an application, I want to book a flight? Ticket to Seattle, go to location. Let's see, what else does it have here? Book me 2 tickets to Paris. Ticket to Paris, book a flight, buy a plane ticket, reservation, train. So there are a lot of ways to say I want to travel. Those are my utterances. So in training my model, what I try to do is you find all the possible phrases, an example of what a user might say, and add it to this list. The entities are the dynamic things. For example, the airline is an entity. I can say go to France. I can say go to Paris. I can say go to somewhere using KLM. The phrase doesn't change. The only thing that changes is the airline, the city, the destination. So that's my entity. Entities can be created, or you can use the pre-built ones, which are a lot, I don't think. Age, dimension, email, geography, which is city, country, state, province, key phrases, money. All those are pre-built entities that you can use to take the temperatures, let's say. For example, temperature. I'm building a home automation system, so I want to tell the system to lower the temperature or increase the temperature. The phrase increase or lower is the intent, but the temperature is the variable, my entity. And you can find pre-built domains. So if you're building a system to use a calendar, email, home automation, these are all domains that you can pretty much add and use right away. One of them is the weather forecast. It's an example of a lot of phrases that say how it's done. When you're creating your model, you can also use a language. It supports a lot of languages, so I think it supports Greek as well. So you can go ahead to the service when you create your application and add the language to be built on. So actually that's it. You find all the probable phrases the system can say, declare which are the entities, and you can actually stop here and just train, test, and publish it. But you can improve the performance. Okay. For example, you can use patterns. There are certain patterns people speak even within the same language. So you select an intent and you type in templates of what you expect users to say. So you create patterns of things, of how Greek people ask for directions when they're speaking in English, or what Russian people use when they're speaking in English. So you create patterns and phrases for specific user groups. So that's how you train your model. Well, it's up to date. And then you can quickly test it. So I can type a test utterance. What can I type? I want to go to, where do we want to go? Well, nowhere, there's a pandemic, but let's say I want to go to, I don't know, no, Paris, I think it was one of the examples. Let's find something else. I don't know, Africa. Okay, let's inspect the results. So what this portal does is create an API. You would send this phrase in as a REST request. And these are the results you would get. So this is the user input. This is the top scoring intent. So the system thinks that by 77%, you want to book a flight. If that's not correct, you can go and assign it to a new intent. That's how the system learns from itself when it categorizes things wrong. It doesn't have any predictions. Composite entities are entities, as we saw previously, that are created by synthesizing two other entities. We don't have those here. And it said that Africa is location. So it identified that Africa is somewhere I want to go. And we don't have patterns. And I probably didn't enable sentiment. You can even enable sentiment to analyze. So what this little portal actually does is just take a phrase and assign it to a group. So let's say I had call center. Well, there are actually call centers right now. If you call a bank, if you call my bank, and it says, hello, what do you want to do? And I say, I want to check my account balance. And there's an automated system that analyzes the I want to check my account balance and assigns me one of those options. and then it goes to another service that informed me of my balance, or it connects me to a representative. This is the how Lewis works and what it brings to an application. So when I have a bot and I don't want to connect it to a person, this can be added to a messenger bot. So it would say, hello, what would you like to do? And as soon as the user types something, I'm taking this phrase, I'm hitting the API, I'm getting the intent of the user, and then I can present him with different choices, or I can connect him to a human person to speak. So that's what Lewis AI does. We can see the same pattern here. We have a model, we're building it, we're training it, we're testing it, and publishing it. So the cycle never stops. Lewis also keeps versioning on this service. So that's all you need to do regarding Lewis service. And the last thing we're going to do today, we're going to see today are bots, or as we refer it to, conversational AI. Well, conversational AI is a solution that enables a dialogue. So conversational AI agents are known as bots, and bots can engage over multiple channels, whether that's web chat, email, social media, voice, call centers, Viber. We have bots everywhere right now. There are responsible AI guidelines for bots, and that could be a question on the exam. They have to be transparent about what they can and cannot do. It must be clear that the user is communicating with the bot and not an actual person. When the bot hands off the conversation to a representative, it must be seamless and not cause frustration to the user, if necessary, if it can be avoided. The bot must respect the cultural norms. You can't build a bot to harass people. Well, you can, as long as it's, well, for humor and not for business purposes. You must make sure the bot is reliable. When I'm typing into my application and I have a complaint, or for example, I was returning a book on Amazon yesterday, so I opened the chat and I requested replacement and a refund, etc. I want to be sure that this is going to go to the seller and not be, not sure. It must be reliable. It must respect user privacy. Data that someone types are still data and still sensitive, and are governed by the same rules you would in any other site and application. So if you have a bot and someone types in health data, you must make sure you have the certifications to gather and do those data. It doesn't matter that it's not a site or form. The data must be handled with the same sensitivity as anything else. It must be accessible by people that are or either blind or hearing impaired. If the bot responds in voice or something, it must meet accessibility standards. And the accountability for the bot is the owner. We must make sure of that. Besides the bot service, there's the Q&A maker service. This is a very interesting service because you can build a bot by using a knowledge base. So if you have a question answer purse, for example, from an existing FAQ document that can be online, you don't have to create something specific. It can take these question answer pairs and create a bot from them. A simple bot. It can't do a lot, but it can create, and we're going to see an example right away. If you're not looking for something as simple as that, you can use the Azure bot service. It's a cloud platform for developing and managing bots, and it can integrate with Lewis to understand intents and do a lot of things and respond to the user appropriately. You can use even Q&A maker along with Lewis and other services. And the connectivity is through multiple channels. You can publish this bot right from the Azure service to any platform like Messenger, Facebook, etc. You still have to go the Facebook review, and you'll have to have like a Facebook developer account, but you can manage it from the Azure portal. And You can even make any combinations you feel like it. So let's go see a demo on it. Let's go see. So this is actually a bot I created for, which is the Q&A maker. These are some knowledge bases. These are some bots I have created. Let's go to the code stories bot. This is my blogs bot. So when you create a bot from the Q&A maker service, let's go back. You still have to have some an Azure subscription. You see here it says the knowledge bases, and if you choose a subscription, you can see the services. So you have to go back to the portal, create a Q&A service. It actually has very good information when you go to create a knowledge base. So it guides you through the whole process of creating and publishing Q&A bot from a knowledge base. You can even add chit chat to it. So if the phrase someone sent to it, it's something, well, meaningless, you can even answer professional, friendly, witty, caring, enthusiastic. And you create your knowledge base. As soon as you create your knowledge base, I'm going to go back and find a ready-made knowledge base. What it does, it goes and converts those question answer pairs to a bot. So this bot has the witty template. So if you ask it something, well, meaningless, like this is a set of questions, someone can ask it, and this is the probable answer. And then what I did is I created a knowledge base of all my articles in my blog, and I fed it to this service. So if I go here, I have the article title and the probable response. So it gives you the link of this base. So you can save and train it. You can test it through the portal. So I can say hello. Well, it will say hey. I can say what's up. It says meaningless conversation. But it will still answer with some kind of witty response or professional response, or anything. I can try it. And if I want to know about customer vision, for example, that we talked about in this presentation, it will suggest articles based on the question answers I have fed it. And it does all of this without a line of code. You can create this through the portal. Okay. And as soon as you're done with your bot, you can publish the service. Okay. I think this is published, but this is a next version. Let's go back to the Azure portal and say how we manage a bot. So this is the Azure portal. I'm gonna go let me find my bot code. Let's see. I'm gonna go to my resource groups, actually not resources. And I think that's it. These are the services needed for a Q&A bot to run. If you go from the Q&A maker portal to create a bot, it creates this service. It's a search service to search for questions and answer in your bot. A couple other services, because this is actually a site. This is published on the internet in the form of a website. So here in the overview, if I open my web app bot and go here, this is the messaging endpoint, but I think this is an actual site. You can check. I don't know if it's accessible right now. Let's find out. Oh, your bot is ready. So this is published on this website. And if I want to test it, I can test it either in the portal or within Azure. There's a test in web chat. So I can make tests here. as soon as it loads. Here, I can find the channels I want to publish it. So it's running on Facebook. Oh, that's great. The web chat has a lot of issues. That's great. These are all the channels Azure supports. Web, direct line, I think that's for handoff to a human agent or something. You can create a Teams bot, Alexa, Telegram, and all of those choices. I will remind you here that when you publish a bot, for example, in Skype, you don't read any kind of review process. But if you do it on Teams, or if you're going to do it on Facebook, publishing on Facebook and other services might have different guidelines for publishing bots. So you have to follow theirs as well. Here, you do all the management of the bot. And you can actually put your bot anywhere. It gives you a bot embed code. And if you go here, it's the web chat. So it gives you a key, a secret key, and the embed code. You paste your secret key here. And we're actually going to see this in action. This is my website, codestories.gr. And you can go here, it's my bot, and I've actually played around with it. So looking for custom vision articles, looking for Lewis. It responds with actually a Lewis article from multi-years ago, but well, it's an article. So you can actually create a bot and embed it anywhere you want. What's the secret key on the HTML? I saw a question. The secret key is the, okay, so let's go back to the services. Every cognitive service requires an endpoint and a key to work. So these keys are here. And usually Azure gives you 2 keys. These are keys here, the secret keys. If you have the keys, you can manage my bot, or you can embed it anywhere. And that's what I don't want. It's not safe. So every cognitive service to work has to have an endpoint and a key. This is also true for machine learning, any API. These are the keys it uses for the API. And that's why all the services have 2 secret keys. So you can use one, and if for some reason that is compromised, leaked or anything, you can regenerate it. But it can take a little time for this to take effect. So you can have a backup key that you would use for your service. So you can regenerate the first while the second is in use, or the other way around. So you can have your service app all the time. By using the keys and the endpoint, what Azure does actually is gather metrics data and billing data. So how much you use your service, how many times the API was hit is governed by this. So if my key, for example, leaks, everyone that can write an API can use my endpoint to make text analytics on their application and not be paying for it. So be very vigilant for your keys in the portal so they don't leak or compromised in any way. And this is the key you use here. Okay. So this is a very brief overview of everything. Actually, it's all the cognitive services, all the services and tech and tools you'll need for the service. So I hope you got a very good idea what you might encounter in this exam. You have to know the basics of all the services. How to use the basic concepts, what are cognitive services, how do we use them, what's an endpoint, what's a key, what's a feature, what's classification, what's regression, what we say when we say machine learning algorithms, what are models, what is training a model, what is publishing a model. So you must be familiar with all those concepts if you're planning to give the exam. And then you have to be a little up to date. You have to know which services to use at any given time, because there's going to be another event where we do the specific preparation for the exam, where we'll see sample questions and we'll see sample solutions and the structure of the exam, how you answer them, how long it takes. But you must be familiar with all the concepts we talked about today if you want to succeed in passing the Azure AI-900 Fundamentals, AI Fundamentals certification. So this is a brief overview of the content. Studying for this exam, well, the first step is going through the Microsoft Learning Paths. It has 5 learning paths that get started with artificial intelligence, no-code predictive models with Azure Machine Learning, explore computer vision in Microsoft Azure, natural language processing, and conversational AI. Those are the recommended Microsoft Learn courses if you want to get started with the certification. My suggestion is to go find Microsoft Visual Training Days. These are actually the planned virtual events for February, and I think there are some in March or not. No, these are just for February. So you can go and see a day, an event where you have the opportunity to expand your skills regarding the AI fundamentals, let's say, or any other 365 virtual training days. It will cover a lot of the skills that are covered in the exam as well. And bonus, in some virtual events, you are eligible to get a free voucher to take the exam. So research, go to US Training Days, register. I think they're free. And they are 1 or 2 day exams. So there is a lot of ground you can cover using those exams. And of course, if you choose to, there's always instructor-led training. You can find a Microsoft certified trainer that can get you through the labs and all the content to help you pass your Microsoft Azure AI Fundamentals. I'm going to publish this presentation in my blog along with the video as soon as it's uploaded. So you can find the references and all the links for this certification and everything I have used for this presentation. So you can explore, let's say, natural language processing, bots, LUIS, etc. If you want, you can go through my blog. A lot of what I've talked about are already there as how-to tutorials, and a couple of them are in videos as well. Or you can wait and see the presentation recording again for maybe something you missed or something you would like to clarify again. If you have any questions, you can follow me on LinkedIn or my GitHub or Twitter, and I'm always happy if you drop me a line and I can help. I try to answer everyone that needs assistance. Let me see. I think I answered all the questions prior to the break. I see a couple other questions. No, that's not the secret. Bot. Okay, I'm gonna take them by. Okay, could you please verify your secret key for the bot is this? I will check and let you know in a second. And the second question is where will the event be? The next event be? I don't know. You follow the group in LinkedIn. Okay, something's wrong. Hang on. Follow our group in LinkedIn where you can get notified of all the information regarding the next events. I don't know when that event will be. And there's another question by Argyris. Let's, but I can't find the link. So give me a second. Okay, I lost my bot. What happened there? Okay. Let me see the questions again. How about a free rider offer from over here? I can't say officially, but I think we might be able to do something in the following events regarding free vouchers. I don't have any so far. But I know that we're trying to get you as many opportunities to get the exam as you can. So let's see channels. Secret keys. Type in your questions while I'm trying to verify the key. Yes, Argyris, that's the key. Regarding the iframe, I'm guessing you did some JavaScript in there. But don't worry, this key won't let you. You can't use my service by using this key. All you can do is embed my bot to your site. You could say it's a bit unsafe. But for example, if you would put it in a SharePoint or in safer, let's say, environment where only specific user have access, it shouldn't be a problem. Any other questions? Okay, I don't see any other questions. I'm gonna thank you everyone for participating. And I hope to see you in other Microsoft Certified Professional community meetups following the next few weeks and months. And thank you very much for staying with me until the end. I think we can wrap this up.